Hello, everyone. I'm Ariel Weisberg, as mentioned. I work on the Presto team at Meta, and this is Scaling, Not Failing with Presto on Spark. I'm going to start by going over the motivation for Presto on Spark and how we arrived at this particular design. After that, Shradha from Intuit, who are one of the early adopters of Presto on Spark, is going to talk about their experience. This isn't going to be a particularly deep technical dive given the 30-minute time slot. One of the problems we see on a regular basis is engineers struggling to choose which compute engine to run their query on or how to build their framework or application to leverage different compute engines. They don't necessarily understand the capabilities of each system, the trade-offs in the different SQL dialects, and the compute needs of their queries in terms of memory, CPU time, wall time, and the query optimization and evaluation capabilities that are available. People do seem to generally like Presto. It's got great error messages. It has very fast startup time out of the box. The SQL dialect is pretty rich and full of features. And for the vast majority of queries, especially interactive queries, you can get by without running into problems without having to work too hard. But when you do run into problems, such as running out of memory or long-running query reliability, it can be quite painful, especially if you have significant investment in a complex application, framework, or heavyweight query. By number of unique queries, we generally see Presto having more adoption than Spark. But when you look at compute volume, Spark tends to dominate. This isn't very surprising because the compute will tend to gravitate towards the engine capable of running larger and more heavyweight queries. Presto was built for the ground up for interactivity. It can run small to medium queries with very low startup time and relatively low latency. Despite being built primarily for interactive use cases, Presto still sees wide adoption in scheduled workloads where resource errors, such as time and memory limits, are more common. The preference for the Presto experience is strong enough that people are willing to accept occasionally having to go and fix something they wrote weeks or even months later just to keep it running. Presto is also ANSI SQL compliant. Compatibility with ANSI SQL makes it more intuitive and easy to use. However, Presto has many limitations I've already hinted at. When users are trying to use Presto to process larger data sets, or when their data set grows naturally over time, they often hit a scalability wall. This can be queries not having enough memory to complete aggregations or joins, or it can be that the queries run for a long time and risk failure due to the lack of fault tolerance and parallelism that is available in Presto. This translates into a more labor-intensive query authoring experience, as well as an ongoing maintenance cost with scheduled workloads. Despite that, in practice, we do see people bending over backwards to stay on Presto. They will split queries up into smaller pieces to make them fit, or optimize their queries both via session properties and SQL. And then, if that doesn't work, they'll use some other compute engine. And having to go down both of those roads, usually serially, adds a lot of overhead. Spark, on the other hand, can offer practically unlimited scale. It can reliably process petabytes of data. It can throw hundreds of terabytes of memory and thousands of CPU cores at a single query. It's the tool of choice for your queries, but when you need it, you really need it. But at the same time, Spark has startup time overhead for short-running queries. This translates into a worse user experience and can also translate into a loss of efficiency on large enough workloads as resources are reserved while executors are busy starting. The HQL interface has a significantly higher learning curve as it is not ANSI compliant. This is something that is improved on if you can use Spark SQL, or even better, the newer ANSI compliant mode, but that also means you need to be on the right version of Spark. And if you do have access to a solid SQL dialect, the transition from Presto to Spark is still painful because there is no UDF compatibility and subtle differences in how queries are expressed. And if you're optimizing to have some engine available that's good at short-running queries, you're going to be in this dual world. Based on the feedback that we have received, people don't want to learn two SQL dialects. They usually prefer sticking to one if possible. And this is where Presto on Spark comes in. The goal of Presto on Spark is to provide a single unified SQL interface to interact with both engines. With a single SQL interface, users will be able to leverage the strengths of both Presto and Spark without spending too much time learning different technologies. I'm going to back up a bit and talk about Presto's architecture so we can understand how that ends up differing from Spark's and what the trade-offs are. Presto is designed for interactivity. Multi-tenancy is implemented as multi-tenant JVMs that are always running and ready to concurrently schedule the tasks that make up a query. Intermediate data is streamed directly from stage to stage of query execution, and Presto tries to run as many stages of a query as possible at the same time. This is why you get results immediately from Presto before the query completes, and it is where the name Presto comes from. Presto, you have your data. Because the stages are scheduled concurrently and stream results directly, everything has to fit in memory at the same time, all your hash tables, etc. Streaming shuffle is limited in the number of workers that the data can feasibly send to before shuffle performance degrades, and fault tolerance is unsupported. Long-running queries get to be very unreliable, as a single worker failure can result in every query in the cluster failing. For long enough duration queries, it's not unexpected to see a failure rate greater than 50%. The shared JVM with no isolation makes it possible for a single bad query or bug to bring down multiple queries. For interactive workloads, this is generally less painful, but for batch workloads, it is much more common to have long-running or memory-hungry queries that can both be the cause of and victim to failure. Spark was designed from the ground up to support granular failure recovery and has fully isolated query execution. The Spark driver is basically providing a coordinator per query, which helps with both isolation and scaling to a large number of executors. Spark supports thousands of executors, and each executor can contain multiple threads. Executors are isolated containers running a single JVM and query at a time. Shuffle is pluggable and can be significantly more scalable, scaling to tens of thousands of partitions, in addition to helping provide fault tolerance. Fault tolerance makes leveraging elastic capacity that may be added and removed on short notice much easier without having to fail queries or waste compute. Additionally, it helps with prioritization and preemption and resource fungibility. Presto on Spark runs almost all of Presto inside Spark as a library. As a result, it starts with 100% query compatibility, including user-defined functions. None of Spark's SQL evaluation code is reused. Scans, joins, aggregations, table writing, connectors, all use the same Java code that Presto uses. Another advantage of this high level of reuse is that Presto's query federation capabilities continue to work. Presto on Spark starts by generating a logical plan as usual, but with converting it to a physical plan, we map to an RDD that is configured to use Presto for evaluation. Spark takes care of scheduling tasks, rescheduling them if they fail, and a shuffle service such as ESS takes care of exchanging the data between stages and assists with fault tolerance. Spark doesn't know anything about the schema or data because we're integrating at the RDD level and exposing very little to the RDD mechanism. This shows the conversion of a logical plan to a physical plan. The stage boundaries, I did not know this was animated. The stage boundaries and operators in each stage are identical between Presto streaming execution and Presto on Spark. This all occurs in the Spark driver process as part of building the RDD. Where things differ from Presto is that instead of a coordinator going into a loop, dispatching tasks to Presto workers to run a query, we instead define an RDD so that Spark can do it. We ask Spark to parallelize splits. A split is a portion of a table scan, and that will translate into a Presto task per split. And then we partition based on the number of output buckets we want for non-leaf stages. Internal stages will all be partitioned on bucket rather than key, as we do our own batching of rows in and out of the shuffle service and pre-partition in order to boost shuffle throughput. Coming back up a level, Presto on Spark pays a higher latency cost for stage boundaries, as they can't be executed concurrently if there is a dependency between stages. But by using a shuffle service, we can partition over a much larger number of disk-based buckets as opposed to in-memory cluster nodes, and we don't need to process all the buckets concurrently, thus avoiding needing to fit everything into memory at the same time. We can process as many or as few as we have available capacity. This is part of how Spark can achieve near unlimited scale. Processing of a bucket can also be retried, which means that we can support preemption and elastic capacity without wasting CPU or unduly increasing latency. Efficiency-wise, despite some additional overhead from disk-based shuffle, we generally see a higher level of efficiency from Presto on Spark. For long enough running queries, we also see lower latency due to the additional parallelism available. So to summarize, with Presto on Spark, we can run queries that would be too unreliable on Presto due to query duration. We can also run queries that would have taken too long because we couldn't apply enough parallelism. We're also able now to run queries that would have used too much memory for Presto by leveraging Spark's ability to partition over distributed disk instead of being limited by the memory available in a cluster. We can also better handle skewed memory usage. Operator spilling works better in the fully isolated container model. Only the tasks that need to spill cause spilling, and noisy neighbors in a shared JVM can't cause other queries to spill, degrading efficiency. All right, Shradha, I'll hand it over to you.
All right. Thanks, Ariel. So I'm going to talk about the experience of using Presto on Spark at Intuit. Before that, I will talk a bit about Superglue. So Superglue is a homegrown tool which is built at Intuit that helps users build, manage, and monitor data pipelines. The primary personas of this is analysts and data scientists. It is built. It was built to democratize data, and so Superglue minimizes time spent developing and debugging data pipelines, so that analysts and data scientists can maximize the time on building insights and AI ML. So Superglue allows you to create pipelines using Hive and Spark SQL, but now we have added support for Presto as well. So let's look at the problem statement. So many analysts at Intuit use Athena, Presto SQL for the data exploration. And then they come to Superglue to create the pipeline, but then they have to manually convert those queries from Presto SQL to Spark SQL. And as you all know, that query translation is not fun, it is tedious, and it can take multiple cycles before successfully translating your query. So let's look at the pain point, right? So as I've explained earlier, query translation is the main pain point. And if you look at the journey map of a typical analyst, right, they're doing the conversion between exploration and processing, and then they do the conversion back from Spark SQL to Presto SQL for visualization. But it's not just the SQL conversion that is painful. So there's an aspect of query performance also. So if you are writing queries, if you're doing conversion and writing queries in different dialects, you can write the query, you can write the optimized query which fits to one dialect but may not work on another dialect. Or there could be some tuning parameters that you're applying for one dialect which may not work for the other. And then there's definitely involved, right? You have to learn new technologies. There's a learning curve. So which overall leads to productivity loss, right? So instead of analysts and data scientists concentrating on building insights, doing AI ML work, they end up doing all this engineering tasks, which leads to productivity loss. So the ask was to provide a performant platform and a simple unified experience to explore, process, and visualize data. And this problem is not specific to Intuit or Facebook, but this is an industry-wide problem. So we evaluated 4 options. So we started with query translation. So LinkedIn has open sourced Coral, which is an query translation analysis and rewrite library. So it takes Hive SQL and converts it into Presto SQL, but vice versa was not there. And internally, it uses Apache Calcite to manage the common layer. But like query translation is always a catch-up game. It might be easy to translate the most common patterns, but the long tail is always hard. Then we also discussed about building our own query virtualization layer. So that is, we provide a platform that decides on runtime based on the cost and the query pattern and the performance expectations, can decide which engine to execute your query. But then it may require building your own DSL, which requires a huge engineering investment. You have to provide all query patterns. So we had a very tight deadline, and it was it was very difficult to achieve that task in that deadline. And then the last option, and then the other option was, Presto on Spark, which combines the best of the both worlds. So a quick recap on Presto on Spark. So Presto on Spark is run as a library. Presto cluster is not needed to run Presto on Spark, which makes it very easy to set up. It's a Spark application. Query is passed as a parameter. It's implemented on RDT level. So as Ariel has mentioned, it does not use any of the Spark's data frame API. So let's look at this is a sample Spark submit command. So Presto on Spark, it produces two artifacts. So one is the launcher jar that you could see, and the other is the Presto Spark package, which consists of the Presto Spark code and all its dependencies. And you can specify the tuning parameters in the config file. You can specify the connector details in the catalogs file, and then you pass a simple query. So a very high level architecture, and so user submits the query, and within the Spark driver, it uses the Presto it passes Presto, use the Presto library to pass the query, analyze the query, generate the distributed plan. It connects to the Hive meta store by thread server, analyzes the tables, gets the underlying file locations, calculates the splits, and converts it into a Spark RDD to distribute across the cluster. Within a Spark worker, the plan fragment is also serialized and sent to the Spark worker. Within a Spark worker, it converts those plan fragment to Presto operators. And so say in case if it's a scan operator, my input could be splits, and my output could be serialized rows, which are spent to Spark buffer for shuffle. And if it's a join and an aggregation operator, my input could be shuffle rows and my output could be write to the table. So as Ariel has also mentioned, the important thing to note is that within the Spark driver and the Spark worker, it is the Presto code and library which is being executed, but it is leveraging Spark for the shuffle capabilities. We can easily scale to terabytes, petabytes of data. Your queries are launched on isolated executors. You can scale your worker execution, and it can leverage Spark services management capabilities. So a very high level implementation add into it. So the user can now create pipelines via Superglue, Presto pipelines via Superglue. These jobs are running on Databricks clusters. So we are running on Databricks transient clusters to take advantage of resource isolation, minimize operational overhead, and manage cost. And all of this is running on AWS cloud. So you would know, right, when you're running your loads on AWS cloud or any cloud provider, when communicating across multiple accounts, you may have to set up trust relations between two accounts, and you can provide those configurations in the catalog properties. So few key learnings. So the threading model is different for Presto on Spark and regular Spark, and you may find this useful when you try to debug your application or try to debug the performance. So Spark takes one core, Spark runs one task per core. But in case of Presto on Spark, it uses all the cores to run one task. So that means it's running like one task per executor. But within one task, it does another in-memory shuffle, and it assigns sub-partition for every thread. And all the threads run in parallel. And this thread pool is managed internally by Presto on Spark. And you can also set up tune use properties. So there are a couple of advantages that this threading model offers us. So the first advantage is that because now it's one task per executor, you're going to emit one shuffle output per executor. So it overall reduces the load on your shuffle service. And the second advantage is that when you are doing a broadcast join, It will be one copy of data which is copied, or one copy of data set which is copied to every node. So it reduces the overall pressure on memory. And then the other learnings were around tuning Presto configurations. So since our loads were running on Databricks transient clusters, and one job was actually running on the entire cluster, so we maximized on memory configuration so that we can use the entire cluster. And but in case of like default configurations works for most of the simple aggregate and join queries, but if you are doing complex join operations where you are joining tables, you are just terabytes of data, you may have to tune this particular Presto configuration query hash partition count. So let's talk about a few challenges. So the next couple of slides are going to talk about the challenges that we ran into. So the first set of challenges, a conflict between Presto Spark library and Databricks runtime version. So Presto Spark library is built using Spark 2x version, and Databricks runtime uses Spark 3x version. So, but the Presto team has done a very good job in handling conflicts across dependencies by providing class loader isolation. So that's implemented in the library, but we still ran into conflict due to Java library. It impacted a couple of classes. We have applied the patch and it has been working good so far, and we plan to contribute it back. Then the other issue that we ran into was support for running multiple queries per session. So Presto on Spark right now supports only one query per session, but our use cases involves running a SQL script. So as as I mentioned earlier in my previous slides, the Presto on Spark, it produces two artifacts, a launcher code and the Presto Spark package dependencies. So we implemented our own launcher code, which provides this support, and we swapped it. And we do plan to contribute this back as well. Then the third issue here was enabling cluster auto scaling support on Databricks. So with Databricks auto scaling, you can scale up and scale down the cluster based on the stats that you're capturing at runtime. So it's based on your shuffle stats, your execution stats. But then if you are running a regular Spark submit job, it does not support that. It can only autoscale cluster for those jobs that has been created at jar task. That means it requires using a shared Spark session. And because also these clusters are created, these clusters were transient clusters, so the Spark session was initialized at start time. But because we were able to separate out the launcher code with the Spark dependencies, Spark package dependencies, so we developed custom Presto Spark launcher code, which uses the shared session. Then the other set of challenges was lack of DDL support. So we are contributing back DDL support. We have a PR, but as a workaround right now, we execute hide style DDLs. Then the other challenge was that tables created were not discoverable outside SuperView. So it did not have read grants at the metastore level, and we applied a patch to provide that. But as part of the above TDL support PR, we have enabled grant support, so you can easily run grant support query. Then the other set of challenge was processing legacy tables created by Hive. So there were some tables which created Hadoop marker files, and our Presto on job failed because it expected a Parquet file, and we have provided a patch for that as well. So success metrics. So we started doing the POC in April, and in June, and we started onboarding users starting July. So in about 4 to 5 months, we have approximately around 1,300 jobs running in production. It has improved analyst productivity, empowered them to deliver insights at high speed. And we are also going to use this platform for the tax season, for the upcoming tax season. So a quick summary of why Presto on Spark matters. No query translation is required here. That's the biggest one. It can scale to large clusters by taking advantage of shuffle capabilities. It provides, you can run queries on isolated executors. Spark has built-in fault tolerant. You can do task level retries, which can lead to reliable long-running queries. You can also throw in more compute with Spark Resource Manager, dynamic allocation. You can throw more compute per query so that your query runs more efficiently and it overall minimizes the operational overhead. That's it. Thank you.
Cool, thank you. So we do have two questions. Maybe we'll start with Amy's question because it's pretty short. So does this have support for a Hootie file system? So I had to look that up, and it seems like Hootie is part of the Hive connector, and it is just a file format. So it would almost certainly work, but I haven't tested it. We don't have a unit test for it with Presto on Spark. But because it's going through the Hive connector, and we do support the Hive connector, and really any connector can be supported, assuming it's instantiated with Presto and Spark. Because again, we ship the entire Presto code base as this Spark application, so it should work. And then we have a more involved question from Bogdan Kuryulik. I'm going to guess I pronounced that correctly. So what are the current known limitations of the Presto on Spark, if any? And I think specifically they were asking about limitations, specifically the views and ACLs. So I think, the DDL for views, I'm not sure how much of that is done. I guess we're still working on that PR, but they should work because again, it's the full Java evaluation and it's running the full planner, and so it's kind of agnostic to a lot of those concerns, and so it does support all of Presto's permission checks and so on. Okay, we have an anonymous question, which sounds more like a bug report, about 5 GB files in S3, and we should create an issue and look into that. I think I don't think I want to tackle that here. How much time do we have left?
Yeah, one moment. I see one more question from Devesh is asking if Intuit is able to. So we haven't tried Presto Vlogs yet. We have just tried pure Presto and Spark.
Oh, they're asking if I don't actually see the question. Is it in regular chat?
Actually, I see Devesh questions and Himanshu questions.
It's in the chat.
Yeah. Okay.
Yeah.
So I actually would like to answer that question. That requires additional integration work because subbing in Vlogs eval for Java eval is like doing the whole thing again, right? Because we're providing a Spark with Java eval, and now we need to provide it with C++ eval, and that would require additional work. It's something we're very interested in doing.
Great. Let's see if there's any more questions. Going once. All right. Well, thank you so much, Ariel and Shradha. A fantastic session. A lot of good questions as well. Looking forward for Presto and Spark to be adopted in by more platform teams. And of course, thanks for the great open source work on supporting the DDLs as well. Thanks, everyone. Now we're off to a break, and we'll come back in about 30 minutes or so for the last few sessions. Take care. Bye-bye.
Yeah.